Hello to all. I am Dr. Ajay Kumar Sinha, Professor of Chemistry. Today I will continue from the last class. Last class I was discussing questions asked in medical and engineering entrance examination. I have discussed up to question number 233. Now I will continue from the question number 234. Keep your pen and paper with you because it will help you in solving the numericals. Now I am reading the question. The volume of water to be added to 100 cc of 0.5 m NH2SO4 to get DC normal concentration is first option 100 cc means cubic centimeter, second 450 cc, third 500 cc, fourth 400 cc. One more time question I am reading. The volume of water to be added to 100 cc of 0.5 N H2SO4 to get DC normal concentration is first option 100 cc, second 450 cc, third 500 cc, fourth 400 cc. Just to think, you can solve these numericals within 1 minute. Just to think. Now I am giving you hint. Okay. Here actually you have to apply N1 V1 is equal to N2 V2 formula you have to use. Now this question is the volume of water the volume of water to be added, that you have to calculate. Correct? Then here I told you N1 V1 is equal to N2 V2 formula you have to use. Then in question it is given that N 0.5 NH2SO4 you have to calculate water to be added to 100 cc of 0.5 NH2SO4. For what purpose? To get DC normal concentration. DC means N by 10. From 0.5 you want N by 10. Correct? Then now here that 0.5 N, that was normality was of H2SO4, that is the 0.5, and volume is 100. Then N1 is 0.5 and V1 is 100 cc. Now this must be equal to N2 V2. Then N2, actually you want to make 0.1 N. Then now it will be N2 will be 0.1. And what should be the total volume? Then you don't know. 100 cc you want to make 0.5 N you want to make DC means N by 10. N by 10 means 1 upon 10, 0.1. Then volume just to calculate. V2 you have to calculate. Okay. Then what will be the volume? Now easily you can calculate the V2. Then 0.5 into 100, that is equal to 0.1 into V2. Then you will get V2 after solving, you will get 500 cc. Correct? 0.5 into 100, how much? 0.5 means 5 by 10 into 100. You will get 50. And this side 0.1 means 1 upon 10. Then after multiplication, you will get cross multiplication, you will get V2 is equal to 500. Then 100, actually you have 100 cc. Correct? In that you have to add water to get 0.1 N. Then total volume now you calculated 500. In that already 100 you have. Then 500 minus 100, that is equal to 400. It means water required to be added is 400 cc. And correct option is 400. Okay, this question was asked in Karnataka CET. Now next question, actually option is D. Correct option is D, 400 cc. Now next question I am reading. Question number 235. The set of numerical coefficient that balances the equation K2CrO4 plus HCl. Actually reaction is given K2CrO4 plus HCl, products are given K2Cr2O7 plus KCl plus H2O. Correct? You have to, in this reaction you have to balance. Then what are the coefficient that you have to tell? The set of numerical coefficients that balances the equation K2CrO4 plus HCl. Products given are K2Cr2O7 plus KCl plus H2O is option. First option is given 1 1 2 2 1. Second, actually total 5 are there. 2 reactants and 3 products. Hence total 5 coefficient will be there. Then first option is given 1 1 2 2 1. Second option is given 2 2 1 1 1. Third option 2 1 1 2 1. Fourth option 2 2 1 2 1. And fifth option, 5 options are there. Fifth option 2 2 2 1 1. Then this you can solve only by balancing. Without balance you can't tell the answer. Then time taken, hardly it will take. This reaction is common reaction. Hence you can quickly balance. And what are the coefficient? Quickly you can tell. Then now you try to balance this reaction. It will take hardly 30 seconds. Now just to try to solve it. Reaction is K2CrO4 plus HCl. It gives 3 products. First product K2Cr2O7 plus KCl plus H2O. Just to balance it. Now I am telling you 2K2CrO4 plus 2HCl. It will give K2Cr2O7, 1 molecule of K2Cr2O7 plus 2 KCl, means 2 molecules of KCl plus H2O, means 1 H2O. Coefficient is only 1 H2O. Then now you can see balanced equation is 2K2Cr2O4. Then first coefficient is 2 plus 2 HCl. Again, second coefficient for the reactants are again 2. Only one molecule of K2Cr2O7 is there. Then here coefficient is 1. For 2KCl coefficient is 2. For H2O only one H2O is there, then 1. Then you can easily you can now see the option, given option, choice, quickly you can tell. Then now 2, 2, 1, 2, 1, that is the correct. 2, 2, 2, 2, and then 1, and then 2, again 1, correct. 2, 2, just to see the balanced reaction. Obviously you can just to match it with the given option, then you will find it is a 2, 2, 1, 2, 1, 2, 2, 1, 2, 1, that is the option D. Option D is correct. Actually, you can solve it very easily. K2CrO4 is there. You can balance it. Then K2CrO4. Then K2Cr product is K2Cr2O7. Then Cr2 product, in product 2 chromium is there. But given in given reaction only 1 chromium is there. K2CrO4. It is monochromate. Then obviously that this reactant K2CrO4 you have to write 2 to balance the chromium, because in the reactant only 1 chromium is there. Product side 2 chromium is there. Then you write it 2. That is a very, you got the Q and clue you can got. Now you can easily after that you can balance. Okay. But that is the reactant only 1 chromium is there, but in product 2 chromium is there. Then you have to write the 2 in the reactant. Then if you write the 2, then now H also you have to see, Cl also you have to balance, correct. Then after considering all the things, because 8 oxygen will be there after when you write 2K2CrO4, then oxygen will be 8. Then now 7 oxygen is there, K2Cr2S7. Then one more oxygen with H2O. Then oxygen is balanced. Then here what you have to balance now? Then this 2 potassium you have to balance. Then 4, because reactant now it become 4 potassium. Then 2 is with K2CrO4. Then obviously you have to write 2KCl to balance the potassium. Now say chromium is balanced, potassium is balanced, and now that this after writing the Cl, 2KCl, then the reactant side only 1 Cl is there. Then you have to multiply there with 2. After that all things will be automatically balanced. 2 HCl means now product side you got a 2 KCl. Potassium is also balanced, Cl is also balanced, and H2O, that is also, hydrogen is also balanced. Hence option D, 2, 2, 1, 2, 1 is correct. This question was asked in Kerala CEE exam. Now next question I am reading. Question number 236. 250 ml of sodium carbonate solution contains 2.65 grams of sodium carbonate. If 10 ml of this solution is diluted to 1 liter, what is the concentration of the resultant solution? Molecular weight of sodium carbonate is given 106. Option is given 0.1 m. Second option is 0.001 m. Third option is 0.01 m. Fourth option is 10 to the power minus 4 m. Now, one more time I am reading the question. Listen carefully. 250 ml of sodium carbonate solution. 250 ml. 250 ml of sodium carbonate solution contains 2.65 grams of sodium carbonate. If 10 ml of this solution is diluted to 1 liter, what is the concentration of the resultant solution? Option 1, 0.1 m, 0.1 m. Second, 0.001 m. Third, 0.01 m. Fourth, 10 to the power minus 4 m. This also this numericals you can solve within 1 minute by using same formula N1 V1 is equal to N2 V2. Okay. This question is asked in again this M.Set examination. Okay. Now you try to solve it. It is not tough. Within 1 minute, easily you can solve it. Think it. Okay. Question is not easy. It is easy. No, I'm sorry. It is easy actually. Not this difficult. Molecular weight of sodium carbonate is given 106. Now you just to think. Now I am giving you hint. Okay, you can solve it easily. See, molarity of the given sodium carbonate solution. You have to first calculate. Weight is given 2.65 gram sodium carbonate. Correct? This 2.6 gram sodium carbonate was dissolved in 250 ml. Then what is its molarity? First you have to calculate. Then for that you required molecular mass. Then molecular mass is given 106. Then weight divided by molecular weight. Correct? That is the number of mole. Then that number of mole now is present in 250 ml. Then in 1000 ml, what will be the number of moles? That is the molarity. Then you can write it very easily. That 2.65 divided by 106. That is present in 250 ml. Means 250 ml contains 2.65 divided by 106. Then for 1, then for 1000. Because molarity is considered in 1000, then you will get 0.1 m, 0.1 m. Then now see this molarity you are knowing 0.1 m. Then now you can same formula I can use. Correct? M1 V1 is equal to M2 V2. Now it you are knowing molarity. Hence M1 V1 formula I can use. Okay. Then M1 V1 is equal to M2 V2. Because this solution only 10 ml you have taken. This 10 ml solution you have taken, and you have that this things made 1 liter. This 10 ml of this solution you have diluted to make 1 liter. Then what is molarity? M2, that you have to calculate. Then M1 is equal to 0.1, V1 you have taken 10 ml and you have made 1 liter. Then V2 is equal to 1000 and M2 you have to calculate. Out of 4, 3 you are knowing. Then M2 quickly you can calculate. It will become 0.001 m. Okay, molarity will be 0.001 m. Okay. Then correct answer is option B. Option be 0.001 m. This question was asked in EAMCET. Okay. Now next question I am now reading. Okay. Question number 237. 7.5 grams of a gas occupy 5.6 liter of volume at STP. The gas is first option NO, second N2O, third CO, carbon monoxide, fourth CO2. Again, one more time, I am reading the question. 7.5 gram of a gas occupies 5.6 liters of volume at STP. The gas is first option NO, nitric oxide, second option N2O, nitrous oxide, N2O, third CO, fourth CO2. This also you can solve it within 30 seconds. Just you think. Okay, question is easy. And this question is asked in EAMCET. Okay, just to think. It is not difficult. Now I am giving you hint. Actually, here see in the question, 7.5 gram of gas occupies 5.6 liter of volume at STP. Then what is the weight for 22.4 liter? 5.6 liter weight is 7.5 gram. Then for 1 liter, then for 22.4 liter. 22.4 liter means 1 mole. And 1 mole weight you will calculate. Then after that you will match with molecular weight of the given gas. Simple. Then now you can calculate very easy mass of 22.4 liter of gas. Means that 5.5 liter weighs 7.5 gram. Then for 1, then for 22.4 liter. 5.6 liter weighs 7.5 gram. Then for 1, then for 22.4 liter. It will become 30 gram. 30. And now 30 gram, just to see molecular mass, whose molecular weight is matching with given option. Then here you will find that gas is NO. Gas is NO because N is 14. Oxygen is 16. 14 plus 16, that is 30. 30, you got 30. Then now it is matching with NO. Hence correct option is NO, nitric oxide, first option. If you will consider other N2O, it will be more. It will not match. Third option CO, it will also not match. C12 plus 16, 28. CO2 will become 44. N2 also 2 into 14 plus 16, it will be more than 30. Hence correct option is first option NO. This question was asked in EAMCET. Now next question I am reading. Next question. In a hydrocarbon, the mass ratio of hydrogen to carbon is 1:3. The empirical formula of the hydrocarbon is first option CH, second option CH2, third option C2H, fourth option CH3, fifth option CH4. One more time question I am reading. In a hydrocarbon, the mass ratio of hydrogen to carbon is 1:3. The empirical formula of the hydrocarbon is first option CH, second option CH2, third option C2H, fourth option CH3, fifth option CH4. This question also you can solve within 1 minute. It will not take more than one. Within 1 minute easily you can solve. Just to think it. Here empirical formula you have to calculate. Then just to follow the process how to get the empirical formula. Just to think. Ratio is given, carbon and hydrogen ratio is 1:3. Hydrogen to carbon ratio is 1:3. Hydrogen is 1, carbon is 3. Just to think, quickly you can solve. Now I am giving you hint. Percentage, if it is given this ratio 1:3, then 1:3 means what? Hydrogen is 1 and carbon is 3. It means it is 100%. If you will consider 100% because ratio is given 1:3, then it means hydrogen is 25%, carbon is 75%. Then percentage now you are knowing, carbon is 75, hydrogen is 25, and atomic mass of carbon is 12, hydrogen is 1. Hence this relative number of atoms easily you can calculate. That is atomic, you have to divide by percentage, you divide by atomic weight. Then 75 by 12, you will get 6.25. And hydrogen is 25 and atomic mass is 1. Then 25 divided by 1, that you got 25. Then relative number of atoms you got 6.25 and 25. Carbon you got 6.25 and hydrogen 25. Then now you can see, just to bring it in a simplest ratio. Then you will divide 6.25 and other is 25. Means one carbon is 1 and hydrogen is 4. Carbon is 1 and hydrogen is 4. Because 6.25 into 4, that is a 25. Then now simplest ratio is 1:4. Hence empirical formula will be CH4. Means option 5, fifth option is correct, CH4. Okay. Then now actually this question was asked in Kerala MEE examination. Now next question I am reading. Okay. Next question is question number 239. Among the following pairs of compounds, the one that illustrates the law of multiple proportion is first option NH3 and NCl3, second H2S and SO2, third CuO and Cu2O, fourth CS2 and FeSO4, fifth option FeCl2 FeSO4. One more time question I am reading. Among the following pairs of compounds, the one that illustrates the law of multiple proportion is first option NH3 and NCl3, second H2S and SO2, third CuO and Cu2O, fourth CS2 and FeSO4, fifth FeCl2 and FeSO4. This question also you can solve within 10 seconds. Just to think. Its correct option is its correct option is option 3. Option means C. Option C is correct. Option C is option C is correct. CuO and Cu2O. How? Then Cu and C combines to form two compounds, CuO and Cu2O. Just for 1 minute. Wait, someone has come. No. Sorry for interruption. Now I will continue. Then now I told you that third option is correct. Okay. Now next question I will read. Here I told you reason why this option C is correct. Then here Cu and O combines to form two compounds. CuO, carbon is reacting with one oxygen. It is forming CuO. And this other compound is making Cu2O. Correct? That's why here it is following these things, multiple proportion. Law of multiple proportion. Now, next question. I am reading you. Which of the following halogen can be purified by sublimation? First, fluorine. Second, chlorine. Third, bromine. Fourth, iodine. It is again, you can, by seeing only you can answer. Actually, this earlier question was asked in what I discussed, Cu and CO2. That question was asked in Kerala MEE examination. Now this question is also very easy. This is the which of the following halogen can be purified by sublimation? First option is F2, fluorine. Second, Cl2, chlorine. Third, Br2, bromine. Fourth, I2, iodine. Okay. Just to think, quickly you can answer by seeing only. Just to think. Its correct option is iodine, I2, because it is a sublimate. Hence, it can be separated by sublimation. Okay. This question was asked in Manipal PMT. Now, next question I am asking you. 241. Question number 241. Irrespective of the source, pure samples of water always yields 88.89% of water of 88.89% mass of oxygen and 11.11% mass of hydrogen. This is explained by the law of, option is given, conservation of mass. Second, constant composition. Third, multiple proportions. Fourth, constant volume. Fifth, Gay-Lussac. Again, I am reading question one more time. Listen carefully. Irrespective of the source, pure sample of water always yields 88.89% mass of oxygen and 11.11% mass of hydrogen. This is explained by the law of first option, conservation of mass; second, constant composition; third, multiple proportions; fourth, constant volume; fifth, Gay-Lussac's. Correct? Now you can answer this question. Again, by seeing the question only you can solve it. Okay, just to think. Again, I am reading one more time question. Irrespective of the source of pure samples of water, always yields 88.89% mass of oxygen and 11.11% mass of hydrogen. This is explained by the law of, you have to tell the law. First is conservation of mass, second, constant composition, third, multiple proportions, fourth, constant volume, fifth, Gay-Lussac's. Just to answer, quickly you can answer by seeing the question only, just to think. Its correct answer is constant composition. Correct? 2:1, you know, H2O. That is here actually it is the correct answer is by law of constant composition. Okay. It is very easy. Law of constant composition, H2O, you know, that is water. Then you can solve only on that basis. H2O contains H and O in a fixed ratio by mass. It illustrates law of constant composition. Now next question I am reading. Actually this question was asked in Kerala CEE exam. Now question number 242. A mixture of sand and iodine can be separated by first, crystallization; second, by sublimation; third, by distillation; fourth, by fractionation; fifth, by filtration. Just it will take 2 seconds, 2-3 seconds, just to see. Again one more time I am reading the question. A mixture of sand and iodine can be separated by first, crystallization; second, by sublimation; third, distillation; fourth, fractionation; fifth, filtration. Very easy. This is done by sublimation because iodine is sublimate. Hence correct option is second option, B. This question was also asked in Kerala CEE examination. Now next question I am reading. Difference in density is the basis of first, ultrafiltration; second, molecular sieving; third, gravity separation; fourth, molecular attraction; fifth, atomic absorption. Again this is an easy question. Again I am reading one more time. Difference in density is the basis of first, ultrafiltration; second, molecular sieving; third, gravity separation; fourth, molecular attraction; fifth, atomic absorption. This also you can answer very quickly by seeing the question. You can tell within 3 seconds. Its correct answer is, just to tell, you have to tell the basis of differences in density. Difference in density is the basis of, first, ultrafiltration, second, molecular sieving, third, gravity separation, fourth, molecular attraction, fifth, atomic absorption. Tell me, very easy. Its correct option is gravity separation. Heaviness in gravity separation. That is based on, you can say, difference in density. Hence correct option is C, gravity separation. This question was asked in Kerala MEE exam. Now next question 244 I am asking, that is the prefix 10 to the power 18 is, the prefix 10 to the power 18 is, first, giga, second, exa, third, kilo, fourth, nano, fifth, mega. Quickly you can tell in 3-4 seconds easily. By seeing you can tell. It is a fact, based on fact. Its correct option is exa, 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 10 to the power 18. 10 to the power 18. Okay. Hence option B is correct. Exa means just like a giga, that you know, kilo, giga, nano, like that way. 10 to the power 18 is known as exa, EXA. Hence option B is correct. Now one more question I want to discuss. Question number 245. The modern atomic weight scale is based on. The modern atomic weight scale is based on, first option C12, second option oxygen 16, third H1, fourth C13. One more time I am reading. The modern atomic weight scale is based on, first option C12, second option O16, third option H1, third option is H1, fourth option C13. Quickly you can answer, just in 1 second you can answer. By seeing you can tell. It is a very common things. Think. Its correct option is C12. Always you are using this. Okay, C12. The modern atomic weight scale is based on C12. By definition only. Earlier it was oxygen. Okay. But nowadays it is C12. This question was asked in MP Medical, MP PMT. Okay. Today I am stopping only here. Next class again I will continue with some tough numericals. Okay. Thank you.